discovery, there's lots of little scientists, like little ants, pushing away on the border between the known and the unknown, and you just push away roughly at random, actually, whatever interests you. And occasionally one of these paths leads to something like the electron, or, you know, in modern times you might say quantum theory, you know, very esoteric beginnings, really understanding the structure of atoms. Rutherford very famously, when asked about the discovery of the nucleus, said anyone that says that the atomic nucleus can be used to generate energy is talking moonshine. And he said that, I think, in 1935 or something. By 1939, you know, we have the Manhattan Project on the go, and then you have nuclear power stations, etc. So I think the very important point is, the answer is I don't know, but it's very important that that shouldn't be used to try and only do research in which you can answer that question.
Well, that's in the current climate, especially in Europe and States, do you find it difficult then to present a case for funding for things like CERN, where you can't be the business plan you present alongside that? The end point is
CERN, no, and CERN is actually very interesting because it was set up by international treaty in 1954 as part of Europe's recovery from the Second World War. So it was one of the great European institutions that was going to bring scientists from all over the continent together for peaceful means. It says that in the Constitution, actually. So it's actually protected by international treaty, which is one of the reasons why it builds, or probably the reason why it builds these machines so cheaply, and why the Americans failed to build a Large Hadron Collider. They started building the Super Collider in Texas, and then Congress changed and away went the thunder. So that means that their big projects cost them a lot and have a very high risk associated to them. Whereas the LHC was built on budget by definition, because CERN only has a set amount of money per year it can spend, you get no more. So it was built on budget and roughly on time. The only thing that can happen is that if there's a problem that it slips in time, because it can't have more money. But its money is protected. So nowhere else in the world, and under no other structure, could you build the most complex machine ever built, 27 kilometres of particle accelerator. It's because of the stability of the funding, and it's utterly guaranteed. Because a country, I mean, Austria actually recently began the process of withdrawing from CERN, and they gave up because it changed in international treaties for very small amounts of money, which is not practical. And it is a small. It's interesting. The budget of CERN is less than the budget of Melbourne University. So it built the LHC for the cost of a medium-sized world-class university. It's less than €1 billion a year. And the big universities, or whatever, $1 billion, it makes no difference. The big universities are in the order of $1 billion, whatever currency you like per year, and service as well.
Do you think something like that would get off the ground in the modern climate? Do you think?
Well, we tried. So ITER, which is not doing quite as well, but it's the European Fusion Project is a similar thing, and it's roughly speaking protected in the same way, but not quite. I mean, it's one of the great triumphs of CERN actually, because it does these things. There are 80 countries, over 80 countries collaborating together, and yet it delivers on time, on budget, and time and again it's delivered. I mean, this is, by most measures, the most technically difficult thing we've ever done as the human race. It's on the scale of the Apollo program, and in technical difficulty, arguably greater, or certainly as great a challenge. And the fact that we can do it internationally, absolutely, with global collaboration, I think this is how you should organise things. This is how things should be done.
There's an argument there for creating treaties, because they're very hard to unwind, aren't they?
Yeah, and that makes the construction of these things possible, because if you don't have guaranteed funding, you can't build them.
Is the US involved in that second project?
The US are involved in ET, yeah, I think. I'm not sure, actually. They're involved in CERN, but they're not involved in the treaty bit. So they contribute certain parts, which they did at some high level from Fermilab in Chicago, but they're not part of the running.
I suspect that the tricks that CERN does is whenever politicians will visit to see what their countries are doing, they find all these shabby buildings that look really old and falling apart. That's because all the smarts are inside, but they on purpose do not build very nice, slick buildings.
Is that why the physics building at uni is so...
But so I noticed this when I visited, that it looks so bad, and apparently, I don't know if you heard this, it's part of the how to make it look like they're getting value for money.
There's some nicer buildings. I mean, the LHC, but we're Atlas and CMS Lib is quite a nice place.
That's the only one.
Yeah, building 80 it's called. But yeah, so that will be the answer to all those questions.
Okay, we're going to move on to...
Sorry, if I may just interrupt,
sure, please do,
I just want to run through these little canapes before everyone gets started, in case there's allergies as well.
Hanging on every word.
What are the possible repercussions for the human race if we discover there is life, microbial or even lower plant life on Mars?
I think it's a great question, that, because I suspect we're maybe on the verge of doing so. I mean, if you look certainly over the last 10 or 15 years, you probably know that the idea that there's life on Mars now, or certainly that there was life on Mars, has gone from almost a bit fringy to pretty much mainstream, and that's what Curiosity's up to there, really. Well, it's certainly looking for the geophysical conditions that might suggest that. And I think the big question is, if it's found, is it the same? Has it got the same biochemistry? Did it have a common origin? Because we know that the material that can be shifted between Mars and Earth, and there are Martian meteorites on Earth and there are bits of Earth on Mars, surely, although we haven't found any, but there's bits of Mars on Earth anyway, so we assume so. And we know that biological material can survive spaceflight. So the question is then, did it evolve independently? Which is essentially the question of, is it the same? If it's the same biochemistry, you would assume common origin, and then it got moved around. But so even more exciting would be if it was a different biochemistry, I think, because then what you're really saying, and we actually were talking about this earlier, what you're really saying then is that given the right conditions, life is, it might be too strong, but an inevitable consequence of the laws of physics and chemistry. So, and that I think is the way that biochemistry is going now as well. I mean, there's one of the best theories for the origin of life is that it was in deep ocean vents, hydrothermal vents. And the reason for that is that you've got water, of course, in contact with rock and the minerals that you need for life, and a lot of sources of energy, particularly pH difference. So these vents in the early 3.8 billion years ago, let's say, were alkaline vents, and they're still alkaline vents today, so deficient in proteins, if you like, in an acid ocean. The ocean was acidic at the time. So you've got pH gradient, temperature gradients, the molecules you need and the elements you need for life, and a driver, in particular a driving force, because life is, in physics, is what you term an out of equilibrium system. So it's a system that we exist out of equilibrium with our environment, and that's what it's thought